Got a few things here going on. So, but it's all interrelated. So don't jump ship middle of the thing here. You'll miss something that'll be needed later on. So let's circles. We'll start with the generic equation of a circle. It's x minus h quantity squared plus y minus k quantity squared is equal to r squared. The center of the circle is at hk, and then the radius is r. What's the radius of a circle? You might remember from the measure from the center to the outside of the circle. So that's what a radius is. It's halfway across the circle, basically, is another way of describing that. But the measurement from the center to the outside edge of the circle is the radius, okay? So what we've got to be able to do is take this idea of this generic idea of an equation of a circle and what the center and the radius are, and then take that and find the center and radius from an equation. This one, x minus 5 squared plus y minus 3 squared is equal to 16. Okay. And they generally put one of these on the final. Really easy. It's a give me if you know that stuff. Okay. So the center is going to be at 5, 3. The radius is at the square root of 16. What's the square root of 16? 4. And we're only going to use the positive side of that because it's a measurement. It's a length, and lengths are always positive. So we take the square root of the number that it's equal to, and that'll get us the radius. The center is coming from those parentheses there. Same instructions, find the center and the radius. And our equation is x plus 3 squared plus y minus 4 squared is equal to 36. Number. What's the center? Negative 3, positive 4. The radius, 6. The square root of 36 is 6. Those are our center and the radius given in the equation. Same instructions for example C. Let's throw a little curveball in there. Maybe this is just a slider. Not really a curveball. Doesn't move much. Still something to think about here. Still going to find the center and the radius. What's the center? I agree with the negative 7 part. 0, negative 7. There's nothing subtracted or added to the x, so that's like adding or subtracting 0. So that's why the x value of the vertex or the center is 0. What would the radius be? Square root of 12, but that can simplify. Remember that we can break that down. That's 4 and 3, 2 and 2. A pair of 2, so that's 2 radical 3. And as a decimal, the square root of 12. Yep, sorry, graph. The square root of 12. Let's go 2 decimal places. 3.46 ish. So the 2 radical 3 or 2 square root of 3 is the exact radius A decimal approximation is 3.46 for that. So be able to find an exact and a decimal approximation. So in my calculator, to get the approximation, I did square root of 12. If I did 2 square root of 3, I get the exact same decimal out of that. So you should be able to match those up with those sort of things. Okay, so given an equation, be able to find the center and the radius. What if we go the other direction and they give us the center and the radius and expect us to write the equation? So it's the complement to this. So doing it the other way around. So what letter we're on here? D. Write the equation of a circle with a center at 6, 8 with a radius of 7. Remember the generic form is that. So what goes in the place of h? 6. So we get x minus 6. What goes in the place of k? Minus 8 squared. What is r squared? 49. We get the square of the r. Same instructions. Let's just change the center at -3, 0 with a diameter 10. So this one's a little bit tougher, probably as tough as this particular set gets. To be honest about it, this set doesn't get real hard. Center at -3, 0 with a diameter of 10. Okay. So what's the equation? X plus 3 squared plus y squared is equal to, no, close, 125 and not 100. There you go. Good job. A diameter is all the way across the circle. Remember, our equation has a radius in it, so we got to take half of that. It's 5, and then square it. So that's where the trick comes in on that. That's what makes this one a little tougher because of that. Okay. With circles, that's the only thing we do with those in Math 100 is these things. Picking out the center and the radius from an equation, or taking a center and a radius and building an equation from it. That's what we do with circles in that. All right, so that was kind of the outlier section that really doesn't intertwine with the next few sections that we're going to cover tonight. So buckle your pew belts, as the preacher says, and watch out for your toes. This is a little more involved, but it's a process. So if you'll follow the process that we're doing through this, you're going to be okay. So we're going to learn a few skills, and then we're going to put those skills to work in the process of solving a larger polynomial. Okay. So solving a larger polynomial is our end result goal. That's what we'll finish off the night with. But we got to have some skill sets to go with that. That first skill that we want to talk about is from section R3, polynomial long division. And everybody loves long division, right? But it's actually not that bad. It's a lot of multiplying and subtracting, just like long division with numbers is. But it's the same idea. Okay, so what we're going to start with is just a polynomial, x cubed plus 6x squared minus 8x plus 10. And we're going to divide that by x plus 3. We're going to use long division to do it in this section. Okay, and then we'll talk about when you can use a thing called synthetic division next. Okay, because sometimes you can use long division or synthetic divisions. There are other times where you have to use long division, so that's why we have to learn it, because there's times we're going to need it. Okay, all right, so we're going to learn the process of long division with this easier problem. I'll go ahead and tell you this one, if you encounter this later on, once we've talked about synthetic division, you're going to do this one normally with synthetic division. But the process is easier to learn with one that's smaller like this. And okay, so when we set up long division, we're going to set it up just like you did elementary school long division. You're going to put your divisor or what you're dividing by on the outside. So we're going to put x plus 3 on the outside. And you make your little long division symbol. I hadn't made one of those in a long time. Probably never made one that big to deal with. Okay, and now on the inside, we're going to put the polynomial that we're dividing into. So the dividend is what it's called. So here's the things that you've got to have when you're doing any kind of division with polynomials. Okay, things that you've got to have. You got to have your polynomials in descending order. What's that mean? What's descending order mean? Yeah, exponents getting lower as you go left to right. So start with x cubed, you got to have x cubed, then x squared, then plain x, and then plain numbers. Same thing for the divisor. It needs to be in order as well. Okay, so first thing is you got to be in order for both of them. The second thing you got to have is you got to have a representative for each power, starting with the biggest one for that piece. So for the divisor, the biggest piece is x. So we got x and we got plain 3. We've got everybody we need. This one, the biggest power is x cubed. So we need an x cubed, an x squared, a plain x, and a plain number. We've got to have a representative for all of those. So this one has an x cubed. It has a 6x squared. It has a plain x. It has a plain number. It's got all of them. If there's one missing, then you've got to put a 0 in its place. So if there's a plain x missing, you put 0x in its place. Okay, we'll see some as we do examples where we've got to insert a 0 just to take that placeholder. It helps things line up good. It's not something that if you leave it out, you're going to get confused. That's what's going to happen. You're going to have some extra pieces that don't match up with what I'm supposed to be subtracting from, and that can cause problems. So this one has already got everything that we need. We don't have to insert any zeros or anything like that. So we're going to copy that polynomial inside of the division symbol. All right, so what you want to do then is you look at the front of your divisor, what we're dividing by, plain x. This is why it's important to have them in order. You always look at the first term. The plus 3 doesn't really matter right now. We'll use it in a minute, okay? So we look at this x and we think, okay, what times x will get me x cubed? X squared. That's the way you want to think when you're doing polynomial division. Polynomial long division is all about multiplication. What times x gets me x cubed? It's x squared. So an x squared is going to go on top right here. Okay. The next step, when we did long division with numbers, you said, okay, well, if I was dividing 4 into 75, I'd say 4 goes into 7 one time, and then what did I do with that 1 and that 4? You times it out. 1 times 4 is 4, and then you subtract it. Same thing's going to happen here with this. You're going to times this out. You're going to multiply this out. X squared times x plus 3. This is where the plus 3 comes back. So it's like distributed property. X squared times x That's going to give me an x cubed that I'm going to write right here. Okay? X squared times x gets me x cubed. Then I'm saying x squared times plus 3 gives me positive 3x squared. Okay? This part that's written in blue came from distributive property. Whatever we put up here times that divisor, what I'm dividing by. Okay? Then I need to put parentheses around this and subtract. Always put parentheses around it and subtract. Okay? When I do that, I'm subtracting x cubed minus x cubed. What happens to them? Perfect. That's what we wanted to happen. X cubed minus x cubed cancels out. Then we're saying positive 6x squared, because it's got a plus sign in front of it, positive 6x squared minus positive 3x squared. That gives me 3x squared right here. That's what's left over. I'm going to bring it down. So 3x squared. Just like up here, when I did that, I'd have a 3 left over. Right? And then what did when I was doing this kind of division, what did I do with the 5? Bring it down. Same thing happens here. I'm going to bring the minus 8x down. Okay. I don't have to bring the plus 10 down yet, because how many terms does this have? 2. So I only need that many right here at one time. Okay. I need the 5 brought down here because 4 won't go into 3. So I know I've got to have something else to go with it, right? So then up here, I would say, okay, how many times does 4 go into 35? How many times does that happen? 8 times, right? So I put an 8 up here, and then I multiply and subtract. Same thing's going to happen here. I'm going to look at the front again. I mean, what times x will give me 3x squared? I need an x. I need a 3 and an x. So I'm going to put a 3x up here. Yeah. This is a positive 3x. This needs to be a positive 3x. This is positive 3x squared. I need a plus 3x up here. Okay? So I'm putting plus 3x. Use a different color here. Plus 3x. Okay? Plus 3x, I'm distributing that to the x plus 3. Just like I multiplied the 8 times the 4 on the number problem. 3x times x is 3x squared. 3x times plus 3 is plus 9x. Parentheses, subtract. Always, parentheses, subtract. Okay? What happens to the 3x squareds? They cancel out just like I wanted them to. Eventually, I'm afraid this is going to quit working. So, now, what's negative 8x minus 9x? No, ma'am. I'm subtracting 8x minus 9. I've got 8x, negative 8x minus positive 9x. 8 minus 9 is negative 17. And then I bring down the plus 10. Negative 8 minus 9 is negative 17. All right. Then I look at the front again. What times x would give me negative 17x? Negative 17, right? Negative 17 times x is negative 17x. Negative 17 times positive 3, negative 51. Parentheses, subtract. Negative 17 minus negative 17, what happens to those? They cancel out. 10 minus negative 51. 61. Now, I look at that and I say, okay, is there anything I can multiply times x and get something that doesn't have an x on it? No way. So I know that 61 is my remainder. This is the remainder. Just like here, I get 3. This is the remainder for this problem. Because 4 won't go into it, right? So we know that's the remainder. And there's nothing else to bring down. So when we go to finish this problem off, our quotient, our answer, is x squared plus 3x minus 17. And this is how we're going to write the remainder. Plus 61 over x plus 3. You take your remainder and put it over what you divided by. So it's like we're kind of making a mixed number, is what it's like. Because the number problem, this would be 18 3/4, which is a mixed number of 18 3/4. Like that. That's what this turns into. We're doing the same thing with the polynomial. We just have x plus 3 on the bottom instead of a plain number out of that. So your remainder goes on top. What you're dividing by goes on the bottom. If the remainder is 0, you don't even have to worry about it. It's not going to be there. Okay? Let's look at another one. See if we can go through this process again. All right. Taking 4m to the third minus 8m to the second plus 5m plus 6 divided by 2m minus 1. Okay. So we're going to set it up for long division. So I'm going to put the 2m plus 1 on the outside, or minus 1 on the outside. Division symbol. And then I've got, make sure you're in the right order and you've got a representative from everybody. So I've got 4m to the third minus 8m squared. I've got a 5m and I've got a plus 6. So I did not have to put a 0 in the place of anybody that was missing. Okay. Where do I look at first? Okay. What part of that do I look at? All right. So what times 2m gets me 4m to the third? 2m to the second. 2m squared. What do I do with that? Multiply it back. So 2m squared times 2m is 4m cubed. Should always match that piece that's in front. If it doesn't, you're not doing it right. Okay? Then 2m to the second times negative 1 would be negative 2m squared. Parentheses, subtract. Okay? What happens to the 4m cubes? They cancel each other out. Minus 6 m squared, because negative 8 minus negative 2 is negative 6. Good job. Pull down the plus 5m. Next. Okay, should it be a plus 3m or a minus 3m? Right, we need a minus 3m up there. Good job. Okay, now when we distribute, we're going to distribute a negative 3m when we do that. Okay, so that sign is going to go with us that we're putting up here. So negative 3m times positive 2m is negative 6m squared. Again, It better match that front piece. If it doesn't, something's wrong. Okay? And then negative 3m times negative 1, positive 3m. Parentheses, subtract. Six m squareds go away. 5m minus 3m, 2m plus 6. 2m, what times 2m gives me 2m? Do I need an m? I already got m on it, right? So I just need 1, right? Just need a 1. Just a plain 1. 1 times 2m gives me 2m. So that's why I need just a plus 1 up there. Distribute that. Just going to be 2m minus 1. Parentheses, subtract. 2m cancels 2m. 6 minus negative 1 be 7. 6 minus negative 1 is 7. Is that my remainder? Yes, because it doesn't have an m on it anymore. There's no way I can multiply 2m times anything and get an m back without, or not get an m back. So my final answer then is 2m squared minus 3m plus 1 plus 7 over 2m minus 1. That's my quotient for that division problem. Okay. All right. Let's look at this one. 3x to the third minus 2x squared minus 150 divided by x squared minus 4. So we have our division problem there. We want to set that up to do long division with. This one is one that you would have to do long division with. Synthetic division would not be an option on because it has an x squared on the divisor. We're going to do synthetic division next, and I'll show you when you're allowed to do synthetic division, when it's even an option. It's going to be an option most of the time, but there are a few times where it's not. And it's one of those things where we kind of just got to bite the bullet and learn to do it. All right. So this one, when we set it up, what do we have to do? Okay, so I got x squared and then a minus 4, but what's missing? An x. So I got to put a plus 0x in there because I have a missing term. I don't have a representative for starting with squared, then a plain x, and then a number. I've only got the squared and the number. I've got that plain x in the middle. I got to represent it. Okay. For my dividend, what I'm dividing into, I start with 3x cubed. Got to put it in order. And then minus 2x squared. But what's also missing there? A plain x. So I'm going to put a plus 0x in there. And then the minus 150. It may seem trivial to you to put those in there. It is, but it's important to help you keep things lined up and have a representative, because at some point you're going to get something that has a plain x on it, and you're going to need somewhere to put it. So we got to have a column for that. So now we look at the front, x squared. What times x squared would give me 3x cubed? 3x. There's a plain x right there. Right? Distribute 3x cubed. 0x squared and a negative 12x. Parentheses, subtraction. I should have done that a different way. That's better. What happens to the x cubes? They cancel out just like we want them to. Negative 2x squared minus 0x squared. Yes, stays a negative 2x squared. 0x squared minus negative 12x. Try again. Positive. Double negative turns it to plus 12x. And then I've got, how many terms do I have that I'm dividing by? 3. So I need to bring down the 150 so that I've got 3 things to work with next. So I'm going to bring down my minus 150. Okay. What times x squared gets me negative 2x squared? Just a 2? A negative 2. That's important. So minus 2. Distribute across there. There's negative 2x squared plus 0x plus 8. Parentheses, subtract. X squareds go away. 12 minus 0, still 12x. Negative 150 minus 8. Negative 158. Single negative. Negative 150 minus 8. All right. Now, is that the remainder, or can we divide one more time? Why is it the remainder? Got 2 terms versus 3, and also this is smaller than what I'm dividing by. So that's how I know I'm done. Okay, so that's the remainder right there. So we go to write the quotient is 3x minus 2 plus 12x minus 158 over x squared minus 4. And I'm just going back to that original divisor because it's shorter to write. Okay. Long division. It's long. Not much fun, but it's not terribly difficult if you'll take your time and just one piece at a time. Okay. You can't get in a hurry. You'll miss a sign. That'll mess up the next 14 steps that you're doing. So got to be careful of that. All right. Now let's take that idea and develop synthetic division next. Okay. So this is 3.2 synthetic. Synthetic division is, or it's sometimes called synthetic substitution. If you go search on YouTube for some help for more examples of this stuff, if you search synthetic substitution, it's the same thing. Okay, so if you see some videos that say synthetic substitution, it's said same thing. So what we're going to do is we're going to do some division, and synthetic division can be used with linear divisors. Examples of linear divisors are x minus 5, 3x plus 7, 2m minus 1. Those are linear divisors, meaning they don't have an exponent on the variable. Okay, the exponent, anything with an exponent larger than 1 cannot be used as a divisor with synthetic division. Synthetic division got to be a linear divisor to use. Okay, so let's take our first example with this, and we're taking 5x to the third minus 6x squared minus 28x minus 2. And we're going to divide that by x plus 2. Okay. The first thing you do is set the divisor equal to 0 and solve. Okay. So we're going to set x plus 2 equal to 0 and solve it. I would subtract 2 and get x equals negative 2. And I'll call this our shelf number. When we set this up, it'll make sense. Okay. So first thing you're going to do, set the divisor equal to 0 and solve it. Okay, that'll get you your shelf number. Whether you show that step or not, or you can do a lot of that in your head. It's just the opposite. It's x plus 2, so it's going to be negative 2. If it's x minus 2, it's going to be positive 2. That idea. Okay, all these are going to be that easy. Now the next thing you do is set up synthetic. And this is how you set it up. You make yourself this L shape that's laying down. Usually it takes up 2 lines of notebook paper. You're going to make that shape looking like that. On this little shelf on the outside, you see the little shelf hanging on the left? That's where the negative 2 is going to go. On the top row of inside of the L, a little bracket there, this top row is going to be the coefficients. So for our problem, it's in descending order. We've got 5, negative 6, negative 28, and minus 2. Those are the numbers from our polynomial that we're dividing into. 5, the negative 6, the negative 28, the negative 2. That's where those numbers are coming from. Take the sign that's in front of it. Okay? Now, the next row we will fill in, okay, like as we're doing the work here. The good thing about synthetic division is, you see any variables in there? No, that makes it so much easier to deal with because you don't have to deal with all the x's and multiplying x times x and x times x squared and all that stuff going on. So synthetic division gets easier because you don't have to deal with the letters. It also gets easier because you don't subtract. You always add. Okay? So here's how it works. The first thing you do is drop the 5 down. Drop that 5 down first. And then we're multiplying, just like you do with regular division. 5 times negative 2 is negative 10. That goes right there. Okay. And then you add negative 6 plus negative 10, negative 16. Multiply. Negative 16 times negative 2, positive 32. And then you add negative 28 plus 32, 4. Then you multiply. 4 times negative 2, negative 8. Then you add. That's negative 10. Okay. This is your remainder. The negative 10 is your remainder. So the way it works, you drop the first one down, and then you multiply, get that next place, add. Multiply, get that next place, add. Multiply, get that next place, add. The last piece is always going to be your remainder. That last term is always your remainder. Here's what happens when you do synthetic division. You take the original problem, and it started out as x cubed, right? So we started out, we had 5x to the third power. When we do synthetic division, it takes it down one notch. This is now 5x squared minus 16x plus 4. 5x squared minus 16x plus 4 plus negative 10 over x plus 2. It works. Long division would have gotten us the same answer. Okay? But synthetic division, that amount of work compared to all of that. Which one's easier? Synthetic is going to be easier. It's going to take you a little bit to get notched up on it and being able to do it well, but it is much easier. Okay? Let's do another problem. Example B. Let's take negative x to the fourth plus 3x squared minus 4x minus 5 divided by x plus 3. What's our shelf number? Negative 3. Good. Setting x plus 3 equal to 0 and solving it, you get x equals negative 3. So negative 3 goes on the shelf. What goes on the top row? What kind of one? Negative 1. Positive 3. Oh, we got to put a 0 there because we got a missing x cubed. So we got to put a 0 right there. And then a positive 3. Negative 4. Negative 5. So we had a missing piece, so we had to put a 0 in its place. Okay. What do I do with that negative 1? Drop it down. That first term is always going to drop down. And then what do I do from there? Negative 1 times negative 3, positive 3. Then I add. Multiply, add. Multiply, add. Multiply, add. That's the negative 47 is my remainder. Right? So my quotient is negative x to the third plus 3x squared minus 6x plus 14 plus negative 47 over x plus 3. The mechanics of synthetic division is multiply and add, multiply and add, multiply and add. That's the way you're going to do synthetic division. Now, let's put that to work in breaking down a larger polynomial. So all we've been doing here is just finding quotients. What we want to be able to do is take these these skills of long division or synthetic division and break down a polynomial and find its remainder. And there's a thing called a remainder and factor theorem. You know, it's always fun when you hear the words theorem. My cousin, he's a computer programmer. He's got a degree in math and things from LSU, and he always said, I took enough math classes to know you never take a math class that has theory at the end of it. And he said, and theorems are all in those classes. And he said I learned pretty quickly after the first one that said theory at the end of it. I didn't want any part of those. I wanted just regular math classes. So theorems are good, though. They really drive us and open up opportunities for breaking down polynomials for this one. This one, the remainder and factor theorem. This is basically what it says. There's a lot wordier definition for this, but I don't think it helps you to learn the wordy one. Let's learn what it means, okay? The remainder and factor theorem says that if the remainder is 0, then the divisor is a factor of the dividend. Okay. It also says the shelf number, that's what we've been calling it, is a 0/x-intercept / solution / root to the polynomial. Okay, so this is going to help us in being able to find x-intercepts, zeros, solutions, roots. They're all the same thing for a polynomial that's larger than a quadratic. That's kind of where we're headed with this, is going and finding all the things we found with quadratics. We're going to try to find that for larger polynomials. Those important pieces are the x-intercepts. That's the big thing that we're after here. Okay, so what we're going to do here, we're going to start off with them giving us something to try and decide if it's a 0 of the polynomial or not, and then trying, is this a factor of the polynomial? That idea. Okay, so let's start with example C. We want to decide if K is a 0 for f of x. All right. Here's our function. It's a polynomial, just like we were getting with the quadratics. They gave us this polynomial, and our polynomial for this one is x cubed minus 4x squared plus 9x minus 6. And then they say k is equal to 1. Okay. Now, what we want to do is take synthetic division and test this. So we're going to put the 1 on the shelf. Okay. That k equals 1, it came from a factor x plus 1. Not plus 1, x minus 1, sorry. That's where that came from. That shelf number of a 1, the k value they're giving us, it came from this x minus 1 that we're dividing by. That's really where it's coming from. Okay. Now, what goes on the top row on the inside there? 1, -4, 9, -6. All right. Now, go through the process of synthetic division. What do we do with the 1? Drop it. Multiply it. Multiply. Remainder is 0. That right there, because the remainder is 0, that tells us k equals 1 is a 0 for f of x. It also tells us that x minus 1 is a factor. Okay. Here's how that being a factor comes into play. 1 minus 3 and 6. That turns into x squared minus 3x plus 6, right? Because we broke down the polynomial. Here's the factored form of that larger polynomial. We can factor a larger polynomial using synthetic division. This is quadratic, right? So if we wanted to find the rest of the zeros, we could take this quadratic and set it equal to 0. We wanted to find the rest of the x-intercepts. We get one x-intercept from x minus 1 because we got a 0 as the remainder. So we know 1 is one of the places across the x-axis. We could set this equal to 0 and get the rest of the places it crosses the x-axis, the x-intercepts. It's quadratic. What can we do to solve a quadratic? We've got factoring. We've got the quadratic formula. That's the one I'm going to use most often because it always works, right? So we've got everything we've done with quadratics. Hey, it's still in play. It's going to help us finish that problem when we get ready to do that. Okay. Right now, we're just practicing synthetic division and deciding if something is zero to that. What we're going to do later is finish it off and actually find all of the zeros, all the x-intercepts for a polynomial. Okay. Let's look at another example of just practicing this stuff with synthetic division. Here's our function. F of x is equal to x to the fourth power minus 2x to the third power plus 4x squared plus 2x minus 5. And let's test a -4. Set up your synthetic. 1, -2, 4, 2, -5. What goes on the shelf? Nope. -4. Not going to change the sign of it because we got the value to try. It came from x plus 4 is where the -4 came from. All right. So we've got that set up. Let's run the synthetic division. Drop the 1 down, multiply, add, multiply, add, and then multiply again. So 28 times -4, -80 and 32, -112. Is that right? And then, so that's -110. And -110 times -4 is a positive 440. And that'd be 435. Is -4 a zero to the polynomial or an x-intercept? -4 is not an x-intercept. That's what we know because the remainder is not 0. For that to be an x-intercept, the remainder's got to be 0. Okay? If it's not 0, then it is not an x-intercept, not a factor, not any of that stuff. Okay? All right, let's look at example E. Polynomial, the same one we just used. X to the fourth minus 2x cubed plus 4x squared plus 2x minus 5. And we want to check out k equals -1 this time. -1 on the shelf. Run it through with the synthetic. What do we do first? Drop the 1, multiply. Love it when it works out. So, -1 is an x-intercept, a solution, a 0 to that polynomial. The factoring that happens is we got x. Where did k equals -1 come from? X plus 1. Good job. Yeah, the opposite of that. So, and then the other part is going to be x cubed minus 3x squared plus 7x minus 5. We're going to learn some things here in the next little bit that's going to help us break that down further. Okay, so we're just kind of adding steps here and there to kind of build us up to getting to the next spot. All right. let's try this. Same polynomial. And let's use a complex one. See if we can break it down that way. All right. On the shelf is going to be that complex number. We're going to use the calculator to help us some here. Everything else, setup-wise, is exactly the same. I'm just going to spread it out a little bit so that I've got a little bit more room because I'm dealing with a complex number. It's just bigger. So I just got to have a little bit more room. Okay. Again, I'm going to drop the 1 down. And when I multiply, I'm going to multiply 1 times this. So it's going to be like distributed property. So 1 times 1 plus 2i is 1 plus 2i, right? Okay. And then I'm going to add. What's negative 2 plus 1 plus 2i? It'd be negative 1 plus 2i. Okay. Now here's where the calculator is going to come in handy when you got to start multiplying these complex ones together. Remember that your calculator can do that for you. So we have 1 plus 2i. To get the I, remember it's second decimal place. And we're multiplying that by negative 1 plus 2i. That gets us a negative 5. So that's what goes right there. 4 plus negative 5 is negative 1. That multiplication I can do without the calculator. Negative 1 times 1 is negative 1. Negative 1 times 2i is negative 2i. I'm going to add that together. So that'd be 1 minus 2i. Well, this multiplication, I'm going to use the calculator to help me with. I'm going to say 1 plus 2i times 1 minus 2i. Positive 5. That works out nice. So 1 plus 2i is a 0 to f of x. Notice I didn't say x-intercept. Complex numbers never touch the x-axis. They don't show up crossing the x-axis. But they're counted as a 0 for that polynomial. So when you're doing synthetic division, you can even synthetically divide by a complex number. You could do synthetic division with a fraction even for that. So it doesn't say, okay, it doesn't work if it's complex. No, it works even if it's a complex number. You still can decide if something is a 0 of that polynomial out of that. Okay, doesn't really help us break that polynomial down any, but I just wanted to show you that you can test a complex number using synthetic division. How that? All right. Now, let's get into taking this and working with polynomials and trying to break them down and get factors out of them using the synthetic division. So we're going on to section 3.3. Oops, don't need that many open to it. This one has already got some stuff in it. Yeah, that's note 4. That's the one I want. 3.3 polynomial zeros and factors. Okay, so what we're going to be doing is factoring a polynomial completely. Okay. And from there, if this little statement here, if k is a 0, then x minus k is a factor. All right. Now, let's start with this one. Here's our function. Our polynomial is 3x to the 5th minus 2x to the 4th plus x cubed minus 8x squared plus 5x plus 1. Okay. Our first thing we're going to work on here to build up to being able to factor a polynomial completely is to take a factor that we know already or that they want us to try and decide if it is a factor. So this is just like what we just did. The difference is they don't give us the shelf number, they give us the factor that it came from. Okay. So when I set this up, I'm still going to use synthetic. What's going on the shelf for this problem? +1. Okay. I got a 3, -2, 1, -8, 5, 1. So this one's kind of long, but it's not a whole lot of steps because we're doing synthetic division. It's a lot quicker than if we were doing long division. Okay. So drop the 3 down, multiply, add. What do you know? That tells us that x minus 1 is a factor. The quotient, this bottom row here, this is going to be 3x to the 4th power plus x to the 3rd power plus 2x squared minus 6x minus 1. That's what the polynomial, that's the first step in factoring it, is doing that synthetic division with that factor that they're giving us. Okay. We're going to build up to the last thing we're doing is with polynomials and breaking them down is actually taking and not knowing any of this stuff, taking a raw polynomial and coming up with this stuff on our own. Okay. So right now we're getting a factor to try. Okay. So then we would do some other things. We're going to learn some other things in a little bit that's going to help us break this larger piece down some more. Okay. So let's take another one. Let's look at example B. Here's our polynomial, 2x to the 4th plus 3x squared minus 5x plus 7. And let's use the same one. Let's use x minus 1 again. And decide, is x minus 1 a factor of that? Okay. So set it up. 1 goes on the shelf, 2, 3, -5, 7. Oh, back up. Got to put a 0. Yeah, I got to have a placeholder for the x cubes. Okay. Roll that 2 down there and get to work. It almost looked like it was going to work out for us because we got that 0 there on the next to the last step, but that did not work for the last. So that tells us that x minus 1 is not a factor. Okay. So for this problem, we're kind of stuck at this point. We're going to learn some skills as we go along here. It's going to help us. Well, if that one doesn't work, we're going to try this next one. And we're going to learn that as we go here. All right, so let's take a polynomial and start factoring it further after we've done the first one. So let's take this one, for example. Here's our first polynomial that we're going to start with, 6x to the 3rd plus 19x squared plus 2x minus 3. and they're telling us x plus 3 is a factor. So that when they say it is a factor, what's that mean we should get when we do the division as the remainder? 0. If we don't get 0 as a remainder and they said it is a factor, then we did something wrong. Okay? So we know we got to redo that. Okay? So set it up. 6, 19, 2, and negative 3. What goes on the shelf? Negative 3. Okay? So all this information so far has been given to us. We've just got to put it into work with synthetic division. So what are we doing first? Drop the 6. Yeah, drop that 6 down. That gives us 1. There's negative 3. That's negative 1. That's positive 3. And I got a 0 in the remainder. That should not be a surprise. We should be happy. That means we did everything correctly on that. So what that does for us is it takes that polynomial and breaks it apart to x plus 3 is one factor. The other factor is 6x squared plus 1x minus 1. We want to try to factor this. Factor that further. Okay, it's a quadratic. So to factor it further, I've got to do that x method thing. Okay, 6 times negative 1 gets me negative 6, and add to be positive 1. What multiplies to be negative 6 and adds to be positive 1. 3 and negative 2, right? So that's going to be 6x squared plus 3x minus 2x minus 1. And I'm going to group that. So going back to something we've done before, it's the factoring. So it's coming back. We've got to be able to do that. 6x squared and 3x have a GCF of 3x. Leaves me 2x plus 1. Those two don't have anything else in common except for a 1. And because they're both negative, I can pull out a negative 1. And that'll get me 2x plus 1 in the parentheses. So it factors as 3x minus 1 and 2x plus 1. And then the other factor is x plus 3. There is that polynomial factored completely. This is the factored form. So breaking it down the first time with the synthetic division and then using other skills that we already should possess to get the other factor out of that. All right. Say here's our function 2x to the third minus 3x squared minus 5x plus 6. And they say one is a 0. And we want to factor completely. That's what we're trying to do. But they didn't give me a factor. They gave me a 0. So I got to do a little bit of thinking here on how to get a factor out of that. Okay? So we're going to break down the polynomial no matter what, right? That's what we're trying to do, is break down this polynomial. What goes on the shelf? If 1 is a 0, then 1 goes on the shelf. Where did the 1 come from? right? It's x minus 1. X minus 1 is where this came from, okay? That's the factor that it came from. So saying 1 is a 0 is the exact same thing as saying x minus 1 is a factor. Those are the same. They're just different ways of saying it, okay? Now, let's do our synthetic here so we can break this cubic down into something that we could do something with, all right? So we've got 2, 2 is -1. Yeah, get that 0 as the remainder. That means we did it right. Things went well. So we've got to do some work from here. So right now, we've got x minus 1 and 2x squared minus x minus 6. We're gonna try to break down the second factor a little further, that 2x squared minus x minus 6. We're going to try to do that a little further. It doesn't mean that it always will, but you got to try to factor it more. If it says factor completely, you got to factor it more. Okay, so this will do with the x method. So that's -12, add to be -1. Multiply to be -12 and add to be -1. I think it's -4 and +3. Well, it's just a sign issue. You got to make sure that they're going to add to be the right number. Okay, so you had the right two numbers, just had the sign swap. So make sure you're getting -4 and +3 adds to be -1. If you did -3 and +4, it adds to be +1. So you got to be careful about that. So I'm going to break that down like this. Group. Those have 2x in common. These have 3 in common. So I have my factored form of x plus or x minus 1, x minus 2, and 2x plus 3. There is the factored form of that polynomial. That quadratic won't always factor, but we've always got to, if it says factor completely, we've got to try to factor it. Because if it'll factor and we don't do it, we didn't factor it completely. Okay. Now, the next rung on the ladder to success here is finding the zeros, finding the x-intercepts for polynomials, given one of them to start with. Okay. So we're going to start with a polynomial, and I'm going to give you one of the zeros, and we're going to break it down from there, and we're going to find the rest of them using the skills that we already have for polynomials or quadratics, and that sort of stuff. Okay, so we've got a polynomial, f of x is equal to x cubed plus 4x squared minus 5. X equals 1 is a 0. Bless you. Find all zeros, x-intercepts for the polynomial. Okay. Find all zeros or x-intercepts. Remember, those are the exact same things. Okay. Bless you. So we're going to set up synthetic with a +1 on the shelf. 1, 4, 0, -5. Why did I put a 0 in there? Didn't have a regular x, so I got to have a representative for that. Okay. If you don't put that in there, it's going to, I won't say that it always will mess things up, but it will make things a little more confusing. Even if it doesn't mess them up, it'll just make it confusing. Because you won't have the right pieces in there. All right. Now, drop the 1, multiply, add. If I don't get 0 on the remainder, and they told me that that was a 0, then I did something wrong. I may have miscopied the problem even. So be careful of that. That's your first checking spot. Okay? Now, this is x squared plus 5x plus 5. Since it asked me just to find the zeros of that, well, here's what I've got so far. This is the factored form I have. I'm going to try to factor that quadratic. Is there anything that multiplies 5 and adds to be 5? Well, what's the only thing that multiplies to be 5? 1 and 5. What's 1 plus 5? 6. That doesn't work. So that tells me that quadratic will not factor. But that doesn't mean I can't find the answers to it. Okay? So what I'm going to do is I'm going to set this quadratic equal to 0 and solve it. The way I'm going to solve it is with quadratic formula. So I'm going to do my discriminant. So that'd be 5 squared minus 4 times 5 times 1. That's 25 minus 20. So my discriminant is 5. So that tells me I have 2 real solutions to that. Okay? Because here's doing that discriminant first also helps shorten up my quadratic formula without it being so much stuff and it gets overwhelming. So do that discriminant separate, and then -5 plus or minus the square root of 5 over 2 times 1. So that's x equals -5 plus or minus the square root of 5 over 2. And then our other 0 is the 1 that we started with. So we have 3 solutions to this problem. The one they told us about, the one with the -5 plus square root of 5 over 2, that's the second one. The other one is -5 minus square root of 2, or square root of 5 over 2. Okay, that's 3 solutions. What's the highest exponent in the original polynomial? 3. You had 3 answers. The highest exponent was 3. That's not a coincidence. In math, that's the way it works. Okay, whatever your highest power or highest exponent is, that's how many answers you should be finding. Okay, whatever your highest exponent is, that's how many answers you should be finding. Let's look at another one, and then we'll get into actually doing the full thing next. We've cut down. We're on short rows now, guys. We got several pages left, but we're getting down to the good stuff. All right, so let's look at example F. All right, so here's our polynomial. 4x to the third plus 6x squared minus 2x minus 1. And they're telling me that x equals 1/2 is a 0. And gave me a daggum fraction. That's no fun, but it's doable. Might not be fun, but it's doable. Okay, so setup wise, 1/2's on the shelf. 4, 6, -2, -1. The good news is those are all even numbers except for the 1, and taking half of an even number's doable. That's easy. Okay, so we're just going to drop the 4 and then go take half of it. What's half of 4? It's 2. Add those together, that's 8. What's half of 8? 4. So that's 2. What's half of 2? 1. There's that 0 in the remainder that we should be finding because they told us we would. Okay. From there, we've got a quadratic. We got 4x squared plus 8x plus 2. We're setting that equal to 0. If all I'm doing is finding the zeros of the thing, I'm probably just going to go straight to doing my quadratic formula there. Just because if it doesn't tell me to factor it, I'm not even going to try to factor it. Okay? If it just says find the zeros, then I'm just going to find the zeros. And I'm going to do that the most efficient way that I know how, which is quadratic formula. Okay? So if I do quadratic formula here, I'm going to do my b squared minus 4ac first, my discriminant. So that's 8 squared minus 4 times 4 times 2. So that's 64 minus 32. Is that 16 times 2 is 32. So 64 minus 32 is 32. So I get x equals -8 plus or minus the square root of 32 over 2 times 4. -8 plus or minus. I need to break down 32. 8 times 4, 4 times 2. There's a pair of 4s that I can just go ahead and use that. 4 square root 2. What do I know about these three numbers? They're all divisible by 4, so divide them all by 4. So that's going to be x equals -2 plus or minus 1 radical 2 over 2. And I've got the 1/2 that we started out with. That's 1/2 is one answer. -2 plus radical 2 over 2 is the second answer. -2 minus radical 2 over 2 is the third answer. The highest exponent in the original problem was 3. We should have found 3 answers. That we should always find the same number as the highest exponent. The 1/2 that they told us about. Yeah, the one that they told us about up there at the beginning. Okay. All right. Now, inside of this, what do you do if they don't tell you anything about a zero or a factor? That's where you got to know some other things. So this is same section. This is talking about the rational zeros theorem. Okay. If P over Q is a rational number and a zero of a polynomial. Remember, a rational number is just a number that can be written as a fraction. And we're going to call that polynomial f of x. Then P is a factor of the constant term, and Q is a factor of the leading coefficient. All right. That's a lot of mathy words to mean you take the plain number on the end, you take all the factors of it, divided by all of the factors of the number that's in the front. Okay? So let's look at an example here. I don't know what letter we're on here. G. Let's take an example. Here's our function. F of x, 6x to the 4th plus 7x cubed minus 12x squared minus 3x plus 2. Okay. That's the problem that they're going to give us. Okay. Now, they want us to find all zeros. Remember, zeros are the same thing as x-intercepts. That's going to be handy in a little bit. Okay. The first thing we want to do is list our rational zeros. That doesn't mean that these will work, but if the proper term, I guess, would be possible rational zeros that we could get there. So it's P over Q. So they always put this on the final. Always. every time. It will probably be on the 110 final because it's always on the Math 140 final as well. So the college algebra final, which this course and 110 together is college algebra. So they always put this on the 100 final. They always put it on the college algebra final. The 110 final, this will probably be a question on it as well. So got to be able to make this list. P over Q. For this problem, P is 2, Q is 6. Okay? We want the factors of 2 over the factors of 6. So what are the factors of 2? What are the things that divide evenly into 2? 2 and 1. What are the things that divide evenly into 6? 1, 2, 3, and 6. The entire list is going to be made by taking each of these factors and dividing by each of these. So I'm going to take 1. 1 divided by 1, 1, right? So I'm going to put a plus or minus out in the front. So it's a 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. 1 divided by 6 is 1/6. Okay? Then I take the next factor, 2. 2 divided by 1 is 2. 2 divided by 2 is 1. I've already got that listed, so I don't write it again. 2 divided by 3 is 2/3. I don't have that one listed yet. 2 divided by 6, what's that?
1/3.
It's 1/3. Have I already got 1/3 listed? Yes, I don't write it again. That is my possible rational zeros. Okay, that's our P over Q list is what I'll refer to that as. Okay, that doesn't mean that each one of those is a zero to this polynomial. What it means is if the polynomial has a rational zero, then it's going to be out of this list. So when we've taken, what we've done is we've taken this polynomial and we've narrowed down the possible rational zeros from every number in the world down to 1, 2, 3, 4, 5, 6, 12 numbers, because you could have a positive or negative of each of those. So we've narrowed it down to 12 numbers. Now, when I was learning this stuff in high school, I took college algebra, then we didn't have the graphic calculator that you guys have. We had to just try them and see if it worked. If it didn't work, you tried another one. So sometimes you just got lucky and you guessed and picked the right one to start off with. Okay? You guys have a tool in your hand that's going to help us keep from just stabbing out in the dark and try to find the right one to start with. So what we're going to do is we're going to graph this polynomial with our graphing calculator. That's the next step. You're going to make this list, and then the next step is to graph the polynomial. Okay? And that's going to help us in breaking it down. Okay? So graphing calculator, I'm going to hit y equals, and then I'm going to type in that polynomial just like it's written there. So 6x raised to the 4th. So to get that 4th power, you hit the caret symbol, which is just right underneath clear, and then type the 4, and you're going to have to hit the right arrow key to get out of the exponent. 7x raised to the 3rd. I forgot the plus sign. 7x raised to the 3rd. Yeah, 4 seconds. All right. And then minus 12x squared minus 3x plus 2. Okay. So I've got that polynomial typed in there. I'm going to hit graph. Look at that thing. Got a lot of twists and turns in it, right? But it's crossing the x-axis at some places. What we're going to do is use those places. Okay. What we want to look for is a good number that's easy to do synthetic with. Okay. So I'm going to start on the left and look across. So I'm going to read it like a book. So when I'm looking left to right, I see it crossing the x-axis right here. What is that number? -2. Now what I want to do to make sure that that'll work so I don't waste my time doing synthetic, I'm going to hit trace and then type in -2. Look at the y value. It's 0. That means -2 will work in synthetic division, and -2 is a 0 to this polynomial. So that's the first one I'm going to use. I'm just going to go from right there. I'm going to stop what I'm doing. I'm going to go back to my problem, and I'm going to do synthetic division with a -2 on the shelf. Drop the 6 down, go to work. Notice I got a 0 in that. So if I make myself a little table over here, zeros, x equals -2. That's one of them. How many more should I find? I need to find 4 total, right? I've got one of them. I got 3 to go. Okay. So the next thing that I want to do is go back to my graph and see if there's another one that works. This one right here is between -1 and 0, so it's a fraction. I'm not going to use that unless I absolutely have to. Okay? I think I've got a better one later on here. So this one is a fraction. I'm going to try not to use that. This next one, it's a fraction. I'd rather not use it if I don't have to, because we don't like working fractions, right? It's just, we're trying to make it easier to tell. Well, where's this place? +1. I'm going to do synthetic with that +1, but I'm going to do it on the what's left over from the first synthetic division. Okay, so I'm going to test that first. I'm going to hit trace, and then I'm going to type in a +1 and hit enter, and I get a 0 for y, so that means it will work. Okay, so I'm going to go to my problem. I'm going to set up synthetic right around this guy, and I'm going to put a +1 on the shelf. I'm going to do synthetic on the quotient I got from the first synthetic that I did. I'm just doing it again. Drop the 6 down. 1. And I got that 0 again. So I got 1 as a 0. So right now I've got -2 and I've got +1. That's 2 of my zeros. There's 2 left. Here's the beautiful part. What did 6, 1, and -1, what does that turn into? It turns into a quadratic. If I set that equal to 0, that gives me the option of doing what with it? Factoring or quadratic formula. Either of those will get you the answer for this one. Okay, this one has nice factors. If I do quadratic formula, it works just the same. Okay, so I'm going to do factoring for this one. 6 times -1 is -6. Add to be +1, that'd be 3 and -2. So we'd have 6x squared plus 3x minus 2x minus 1. Group. -1. Okay. (3x minus 1), 2x plus 1. Now, what do I do with each of those factors to get the answers? Did the hard part of doing the factoring, but what do I do with each factor? Set them both equal to 0. Yeah. 1/3 and -1/2, won't it be? That's a +1 there. That'd be 3x is equal to 1 divided by 3. X is 1/3 minus 1 divided by 2. X is -1/2. So I've got my zeros that I found were x equals 1/3, x equals -1/2. Didn't we think that those were fractions when we looked at that graph anyway? Does it make sense that we got fractions as the answers? Yeah, it makes a lot of sense that we did. If we want to check them, if I type in 1/3, hey, y is a 0. If I try negative 1/2, y is a 0. It's the right ones. Okay, so by finding where it's crossing the x-axis, I'm using that synthetic division, using that rational zeros theorem that we were working with. All of that stuff, it just ties all together. It doesn't, it's a lot of stuff. Don't get me wrong, but it ties all together. All right, let's look at another one. Here's our polynomial. X to the third plus 5x squared plus 2x minus 8. Okay, let's build our P over Q list before we start, so that we kind of know what numbers we need to try with our when we get the graph out of this. So on the top, we need the factors of 8. On the bottom, we need the factors of 1. So this one's a little easier to get that P over Q list, because what are the factors of 8? 1, 2, 4, and 8. The factors of 1, 1. Oh man, that list is easy for this one because you're just dividing them all by 1. So it's plus or minus 1, 2, 4, and 8. So we've narrowed it down to only 8 possible numbers for this one. Wonderful. All right. The next thing that I'm going to do is what? With that polynomial. Graph it so I can use, I'm going to use the graph to help me set up a synthetic division with. Okay. So I'm going to take that polynomial, go to y equals, clear out the other one that I was dealing with, go x to the third plus 5x squared plus 2x minus 8. Hit graph. And see where that thing's crossing the x-axis. This one's crossing at 3 pretty nice places. Okay. What's the first one that you think of here that you see? Positive 1 would work great. That's probably the easiest one to do synthetic with. So let's start with that one. That sounds like a great idea. 1, 5, 2, negative 8. I'm going to run synthetic with that. 1. So I get my zeros. X equals 1. I've now got a quadratic, x squared plus 6x plus 8. I can do quadratic methods to solve that. I'm going to use quadratic formula this time. X equals negative 6 plus or minus. I'm going to do my discriminant 6 squared minus 4 times 1 times 8. This table going to have 5. It's a little too short. 36 minus 32 is 4. So we got the square root of 4 there. That's nice. And over 2 times 1 is 2. What's the square root of 4? 2. So we got negative 6 plus 2 over 2. And then negative 6 minus 2 over 2. Negative 6 plus 2 is negative 4. Divided by 2, negative 2. Negative 6 minus 2 is negative 8. Negative 4. Where was that thing crossing the x-axis at? Yeah. All ties together, man. It's all together. You can use it for some shortcut stuff here when it lands on nice places. When it's in between, that's where you gotta really rely on that P over Q list and your other methods for finding those zeros. A lot of times, though, you can get some help by just being able to graph the thing and see where it's crossing the x-axis. That's very, very helpful. Okay. All right. Let's look at this one and see what we come up with here. Show you just a little bit different situation that happens from time to time that you need to be aware of. Here's our polynomial, x to the third plus 3x squared plus 3x plus 1. This one, the P over Q list, is extremely easy because it's 1 and 1, right? So there's only two possible numbers that it could be, positive 1 or negative 1. That's it. That's the ones that I always loved when I didn't have the graphing calculator help, because I didn't have a whole bunch to pick from. Okay. Now, what I want to do is figure out what to use for my synthetic. So I'm just going to graph the thing. X cubed plus 3x squared plus 3x plus 1. All right, this is a weird one. Where's it crossing the x-axis at? At negative 1, right? That's where it's crossing the x-axis at there, is at negative 1. If I hit trace and type in negative 1, I get a 0 for y. So that means I can use negative 1 on my shelf. If I do that, brain froze there for a second. I get a 0 in my remainder. That's what I wanted. But then I've got this quadratic left over. I got x squared plus 2x plus 1. And I'm going to set that equal to 0. All right. I'm going to try factoring. What multiplies to be 1 and adds to be 2? 1 and 1. That's the only way to multiply to be 1 is 1 times 1, right? And I can take a shortcut on the factoring here because it starts with a 1. So it's x plus 1 and x plus 1. Well, that's weird, because when I set those equal to 0, I get x equals negative 1 again. Actually, 2 more times. What that is called is a repeated 0. And the way you note that is with multiplicity, is what you call that. How many times it counts, it's a multiplicity of that number. How many times did we find negative 1 worked? 3 times. So it has a multiplicity of 3. If something worked twice, it has a multiplicity of 2. Something worked 8 times, it's about a multiplicity of 8. That sort of idea. Okay. How many times you find that number as a 0 to the polynomial, it has a multiplicity of that. Okay. Clues to know that something has multiplicity of a certain more than one time counting are when you look at the graph. Notice how this one, if I clear that off, notice how it kind of flat right there when it crosses the x-axis. That's a clue that something special is happening. Another special thing that could happen is if it comes to the I'll graph another one here. Let's say we had x squared plus 6x plus 9. I'm going to show you what that one does. All right, another way that you could see that if you have a polynomial and it comes down and touches the x-axis right there and bounces off, or it comes up from the bottom and touches the x-axis and bounces off, what that means is you got a multiplicity of more than 1. So that value could use more than once. Okay, so you got some clues from the graph for when you have a multiplicity higher than 1. It kind of has a little flat spot right there when it crosses the x-axis, or it bounces off the x-axis, either coming down and bouncing back up, or coming up and bouncing back down. You're going to see those kind of things happening. Okay, so you'll know that should be happening. All right. Let's look at one more solving, and then we'll build some polynomials, and then we'll be done. Okay, so we're going to solve one more from scratch, and then we'll build some, and we'll get out of here. I know it's a long night. I'm as tired as you are. I've been going since about 5:30 this morning, so it's been a long day. So here's our polynomial: x to the fourth minus 7x cubed plus 18x squared minus 22x plus 12. A big one to finish off with. I don't even know what letter I'm on. J. Sample J. Okay. P over Q. Factors of 12 over the factors of 1. What are the factors of 12? 1, 2, 3, 4, 6, and 12. Factors of 1, just 1, right? So those are the numbers that are in our list. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. Those are the things that we can try with our synthetic division, okay? So instead of guessing at which one to try, we're going to use the graph to tell us which ones to try out of this. So I'm going to graph that original polynomial with my graphing calculator. So x to the fourth minus 7x to the third plus 18x squared minus 22x plus 12. And find where it's crossing the x-axis. I see a couple of good numbers. It's like positive 2 and positive 3. Doesn't matter which one you pick to start with. I just know that those are the two that I'm going to use for sure. Okay. I'm just going to start with the 2. It's a smaller number. No real reason to that. If you want to start with a 3, you could. It works just the same. Okay. 1, negative 7, 18, negative 22, and 12. Drop the 1, go to work. Great. So we get our zeros. We get x equals 2. And then I'm going to do synthetic one more time because I know for sure that 3 works as well because it crossed the x-axis there, right? Drop the 1 down, go to work. And there I get that 0 in the remainder spot, so I know that x equals 3 is also a 0 to this polynomial. Now, did it cross the x-axis any other places? No. Those are the only 2 places it crossed the x-axis. That means that's the only 2 x-intercepts, but it doesn't mean it's the only zeros. There should be how many zeros to once we get done? Should be 4 because the highest exponent's 4, right? What's this that's left over down here? The 0 is the remainder. What's the 1, the negative 2, and the 2? Where does that go to? It becomes a quadratic. Yeah, we need to do quadratic formula with that. I'm going to do my discriminant over here on the side. Negative 2 squared minus 4 times 1 times 2. That'd be 4 minus 8, which is negative 4. Oh, we have a negative discriminant. What does that tell us about those zeros? They are what kind? complex. Yeah, so we know the reason that they didn't cross the x-axis anymore is because the other two zeros were complex numbers. So that's why that didn't cross. So I'm just going to go ahead and finish it off. So 2 plus or minus the square root of -4 over 2 times 1 is 2. What's the square root of -4? 2i. Everybody's divisible by 2. So x equals 1 plus or minus I. Those are our other two zeros. X equals 1 plus I. X equals 1 minus I. There's all 4 zeros for this problem. How about that? We're going to do synthetic. Here's the kind of the rule of thumb that you can use when you're trying to solve polynomials. Take the highest exponent and subtract 2. This is how many synthetic divisions you need to do. Okay. Highest exponent minus 2. That gives you how many times you need to do synthetic division. The reason that it's subtracting 2 is because you want to end up with a quadratic so that you can do like quadratic formula to solve the last 2. Okay. So you want to take your highest power, subtract 2, and whatever you get, you're going to do synthetic division that many times. So that's going to help you have a better process, but you got to see a lot at the end of the tunnel. Again, it's all a process with this stuff, and it's not none of the math is really hard. It's just there's a lot of places that you could make a mistake in there. So it's just learning that process. What the heck that was? This place makes some weird noises. I just can't. Never know what's going to be. All right, so let's build a few polynomials and then we'll get out of here. Okay, so building polynomials. What you're going to do is you're going to build a polynomial based on the zeros. On the zeros given. Okay. I think I messed up on my letters. H, I, J. Yeah, maybe not. Okay. Oh. Anyway, so here are the zeros. -1, 2, and 4. And f of 1 equals 3. Okay, so this is the information they gave us. They gave us some zeros, and then they gave us another ordered pair. F of 1 is the ordered pair 1, 3. Yeah, x is 1, y is 3. So that's what that ordered pair is. We're going to use that later. Okay. First thing we're going to deal with are the zeros because that's the hard part. Okay. Now, what we're going to start off with is get the factors that go with those zeros. What's the factor that goes with -1? Where did it come from? Think about back to where we were doing the polynomials before, and they said x plus 5 is a factor. That meant you knew you used what on the shelf? Negative, the opposite of that. So the factor that goes with -1 would be x plus 1. What's the factor that goes with +2? X minus 2, and 4 would be x minus 4. Okay. Now, Remember when we were doing the quadratics, you had this A in the front? Well, that's where the ordered pair is going to come back in, okay? So what I would do here is I would go ahead and find out what A is before I start multiplying this all out, okay? So the way to do that is plug in the ordered pair that you know. We know X is 1 and Y is 3. So I'm plugging that in. 3 equals A, 1 plus 1, 1 minus 2, 1 minus 4. I'm plugging that in. Are any of these math problems here hard? No. 1 plus 1 is 2. 1 minus 2 is negative 1. 1 minus 4 is negative 3. So we have 2 times negative 1 times negative 3. So that's going to be 3 is equal to 6A. How do we get A by itself? No. Divide by 6. 3 over 6 is 1/2. So A is 1/2. So we go back up here and we say f of x is equal to 1/2 x minus, or x plus 1, x minus 2, x minus 4. Now, this is the factored form of the polynomial. What we want to do is multiply this joker out. So we're going to use distributive property several times here. I'm going to start with x minus 2 and x minus 4. I'm going to do all the stuff that's got letters first and then do the 1/2 at the end because that's the easiest one. And it's a fraction, and I don't want to mix fractions with all this other stuff either, right? So I'm going to wait on the 1/2. Because it's all multiplication, it doesn't matter what order I do things in. So I'm just going to pick these two to start with, and I'm going to multiply them together. So if I pick these two, x times x is x squared. X times 4, or negative 4, is negative 4x. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. That simplifies to be x squared minus 6x plus 8. Okay, now I'm going to put these two together. Okay, so I'm going to multiply x times everybody that's in there. Then I'm going to multiply 1 times everybody that's in there. Okay, so that's x cubed minus 6x squared plus 8x. Then 1. So that's 1x squared minus 6x plus 8. Y'all remember doing this where we stacked them up like that? Been a few weeks, but we've done this. Okay, it's all ties together. Everything we've done builds on itself. So add that up. So I got x cubed minus 5x squared plus 2x plus 8. And I still got the 1/2 that's in front. That's the last step, is the 1/2. Distribute the 1/2 to everybody. So that's 1/2 x to the third minus 5 over 2 x squared plus half of 2 is 1, so that's x. Half of 8 is 4. And whoop-de-doo, we got a polynomial. How do I know that that's the right one? I graph it. And it should cross the x-axis at what places? -1, 2, and 4. Okay? So if I graph that, y equals 1/2 x raised to the third minus 5 over 2 x squared plus x plus 4. Graph. There's the -1. There's the +2. There's the 4. It's not very likely that it crosses at all the right places, and you got the wrong polynomial. Okay. Also, it should have the point 1, 3. So if I hit trace and type a 1, I should get a y value of 3. And I do. So you can check by just multiplying it out and graph what your final answer is to get a polynomial built there. Okay. All right, let's do this. Here are our zeros. -2 with the multiplicity. Two and 3. Then f of 2 is equal to 8. Fun times. Multiplicity of 2 means that -2 is a 0 how many times? Twice, right? So our function, we got a, and then we have, what's the factor that goes with -2? X plus 2, right? There's 2 of those because it has a multiplicity of 2. If it was a multiplicity of 3, you'd put 3 of them there, okay? And then the 3, what's the factor that goes with 3? X minus 3, okay? Over here, we got an ordered pair of 2, 8. So we're going to plug a 2 in everywhere there's an X, an 8 there for Y, and try to find out what A is. That's exactly right. That's it. There you go. So 2 plus 2, 2 plus 2, and 2 minus 3. So we got 4, 4, and -1. Again, 8. That's -16. Divided by -16. And we get a -1/2 is A this time. Okay. So that means we're going to have our function to start off with is -1/2 x plus 2, x plus 2, x minus 3, like that. Okay. Start with 2 of them. It doesn't matter which 2. Just pick 2. I'm picking those 2. Multiply them out. X squared minus 3x plus 2x minus 6. Simplify. X squared minus x minus 6 times x plus 2 times 1/2. I'm going to do these 2 together. A little longer on that one. So x cubed minus x squared minus 6x plus 2x squared minus 2x minus 12. Simplify that. 1/2 parentheses x cubed plus x squared minus 8x minus 12. And the last and final step, distribute the -1/2 that we had there. That was a -1/2. I dropped the sign somewhere along the way. -1/2 x cubed, -1/2 x squared, positive 4x, positive 6. Ooh. It's a lot of work. A lot of work. Not hard work. The math is not incredibly difficult. You're not getting huge numbers here, but the process is long and has a lot of places where you could make a mistake. Yeah, so you've got to be very careful with that. All right. 2 more, and I'm done. Okay. 2 more. There's a light at the end of the sun. I know it's a long night, but it's the last one. So hang with me. We've got 2 more problems to do. Here are our zeros. 3 and the square root of 5 and no other ordered pair. Here's the trick to this. There is a hidden 0. If the positive square root of 5 is a 0, then the negative square root of 5 has to be a 0. Remember, with quadratic formula, you always have the plus or minus in the square root. So if there's a square root that's a part of the solutions or the zeros, then there's got to be a positive side and the negative side. So that's why that one's there. They're not going to show you that one. They're just going to give you those two. You've got to understand and know that that one's there. Okay? Then build your polynomial based on that. They didn't give us another ordered pair on this one, so we don't have to find a. So that shortens this up a little bit. Okay? So here's our function, f of x. What's the factor for the 3? Good job, x minus 3. What's the factor for the square root of 5? X minus the square root of 5. What's the factor for the negative square root of 5? X plus the square root of 5. Just because it has a square root on it doesn't change the idea about just changing the sign to get the factor back. Okay? Now, for these, you do want to kind of have do the ones with square roots together first. Don't try to mix and match square roots and non-square roots. Okay? So I'm going to put these two together and do that multiplication first. When I do that, it's still distributed property just like before. X times x, x squared. X times the square root of 5 is x square root of 5. Negative square root of 5 times x is negative x square root of 5. Square root of 5 times negative square root of 5 is negative square root of 25. Simplifying that, those go away. What's the square root of 25? 5. So it's x squared minus 5. Oh, man, that suddenly got a lot shorter. Now we need to multiply these two together, and that's it. X times x squared is x cubed. X times negative 5 is negative 5x. Negative 3x squared, positive 15. All we got to do at the end here, just put it in the right order. The easy part. X cubed minus 3x squared minus 5x plus 15. All right. It saddens me to say this, but this is the last example of the semester for general lecture things. We'll have a few examples for labs next week. I'm getting choked up. But this, I'm not really. I'm losing my voice is what's happening. I've been teaching all day, so it's been a long one. All right, so last example. Here are our zeros. 3 and 2 minus I. Which one is not told? There's one that isn't told. What would it be? 2 plus I. Good. That makes this is going to end well, hopefully. The multiplication stinks on this, but it's okay. It's not a lot of fun, but that, it's math class. I didn't think it was supposed to be fun anyway. Yeah. All right, so now, factors. What's the factor for 3? That's 3. The factor for 2 minus I would be x minus 2 plus I. Change the sign of both of them. The factor for 2 plus I would be x minus 2 minus I. Again, change the sign of both of them. Just like you change the sign of the 3, change the sign of both pieces of the complex. Now, Which two do you think you should multiply together first? The stuff with the i's in it, okay? So we're going to put that together first. And this is the longest part of this problem, is the I part. But the good thing is the i's go away. And if they don't go away, something went wrong, okay? So distribute just like you would any other problem. You're just going to distribute across the whole thing. X times x, x squared. X times negative 2 is negative 2x. X times negative I is negative ix. Then distribute the negative 2. Negative 2 times x, negative 2x. Negative 2 times negative 2, positive 4. Negative 2 times negative I, positive 2i. And give myself enough room. Give myself a little more room. I'm writing too big today. Then distribute the I. I times x is positive ix. I times negative 2, negative 2i. I times negative I is negative I squared. Simplifying this is what gets rid of the i's. Okay? So here I have a negative ix, and over here I have a positive ix. What do? They wipe each other away. Bye-bye. And then I have a positive 2i, and I have a negative 2i. What do? Cancel each other out. All right. I have a negative 2x and a negative 2x together. That would be negative 4x. I have a positive 4, but I also have this minus I squared. I've still got an I in there. What does I squared turn into? You may remember? Not 1, but negative 1. So this is negative 1. What's negative 1? Positive 1. 4 plus 1 is 5. Ooh. That got rid of all of the i's. Now all I have to do is multiply out this stuff. Okay. 4 added together. Plus 4. 4 minus negative 1 would be 4 plus 1 is 5. Now, multiply this out. This is the easy part. As Joe says, you say that about everything. X times x squared, x cubed, minus 4x squared, plus 5x. Multiply everything by negative 3, excuse me. Minus 3x squared, plus 12x, minus 15. Simplify, and be done. X cubed, minus 7x squared, plus 17x, minus 15. And you're done. Boom. Okay. Building polynomials based on those fun things. Okay. All right. When in doubt, graph the polynomial. When you're in doubt about anything on these Canvas quizzes, graph the thing with your calculator. It will point you in the right direction, I promise you. Okay. That tool is important and it's helpful. Okay. All right. Canvas quizzes. Next week we'll do labs and a test. You've got a review for the test coming. It's basically the Canvas quiz redone for the test next week. I also have a review for the final exam and that'll get you ready for next week. And then the final is December the 10th. Our final will begin at shortly after 6. If there are people still in here on the week of the final, I'll say this again next week. Don't come in because they've got 2 full hours. Theirs doesn't start till 4. So our final on December the 10th won't start till 6, till after 6.
So we have to be here for
Yes, final will be in person here, December the 10th.
December 10th at 6 o'clock.
after 6 o'clock, unless everybody's gone from my other class. And they usually are, but the one year that I say that they won't be, they won't be. So
Will you YouTube tonight?
yes, it is. Okay, but yes,